Hi, I'm Carol. We are in the Vectors chapter of Applied Physics 110, working out Problems 3, number 12. You'll find problems at 3 in the text. Follow the text of the reading, and that's where you'll find it. This problem says that we want to go 17 kilometers north. We're going to call that vector A. Put a little hat over it and call it vector A. Then the next direction we'll call vector B, and the third one we'll call vector C. And what we're aiming for is, where are we from the starting point? What's our, as a result of doing all of these directions, of taking all these directions, doing all this walking, so to speak. So let's draw a picture. Picture's worth 1,000 words. I always recommend the picture. We're going to start with an XY coordinate system down here. Start at the 0, 0 point. First thing it tells us to do is vector A. We're going 17 kilometers north. Now I'm going to tell you my drawing is not going to be to scale. I did have a guy in class once draw everything to scale. Didn't have to work out any other problems. Just drew it perfectly and got the right answer. So if you can do that, that's great. But I'm going to show you how to do it the math way. Vector A. We'll draw it in red. Uh, 17 kilometers north. So the x component, this being the x-axis here on the horizontal, and the y going vertical. The x component of this vector A is 0. The y component is 17. We'll go with that. Now we're going to start from where we left off at the end, at the tip of vector A, and we're going to start going, now we're going to start vector B here, and vector B says we want to go 10 kilometers at 7 degrees south of east. So just think of map directions. This is the north, this is the east, south would be down here, and of course west would be on the negative x-axis. All right, so we want to go 10 kilometers at 7 degrees south of east. If that was 17, let's draw vector B in green. Okay, and I'm going to approximate again. This is not going to be the perfect drawing, but we're going to get the math right. We want to be 10 degrees south of east. This is east and south of east, so we're going to be off this direction a little bit. Of course, my line isn't very straight at all, but that's, there you have it, 10 kilometers. And if we break this into an x component and a y component, we've got the, we're going to call this b sub x, we're going to call this b sub y, and we know that, oh sorry, this is 7 degrees, so we have a 7-degree angle here. So you know from your worksheet on SOHCAHTOA, I'm going to write the formulas over here. And that's just a mnemonic to help you remember. SOHCAHTOA, we would say sine of the angle equals opposite side over the hypotenuse. Cosine of the angle equals adjacent side over the hypotenuse. And the tangent, I guess I'll put it down here, the tangent of the angle is equal to the opposite side over the adjacent side. So we got those down. What we have here, we know the hypotenuse of this triangle. We've made it a right triangle. The hypotenuse is always the long side. And we know one side and one angle. So, and the side that we're looking for is b sub x, and it is the side that is adjacent to the known angle of 7 degrees. So we know the hypotenuse, we know the angle, we're looking for the adjacent. Therefore, we're going to use the cosine formula in this case and solve it for the adjacent side. That's the unknown. So we're going to have the cosine of theta times the hypotenuse. So b sub x here is going to be cosine of 7 times the 10. B sub y is the opposite side of this angle. B sub y, we're going to use this the SOH, the sine formula. So, and solve it for the opposite side. The opposite side is the unknown side. If we took the sine of the angle times the hypotenuse, we'd get the opposite side. So let's take the sine of 7 times the 10. And we'll have it. And if we do the math on these, we have to keep in mind that in the x direction, the b sub x is going to be a positive number. The b sub y is going down. It's going in the negative y direction. So the b sub y is going to be a negative number. I can, when I'm putting in my coordinates, I can do this. The b sub x is going to be positive. The b sub y is going to be negative. If I do work out the math, and go ahead and work out the math, go to one more degree of accuracy than you need, and then do all your rounding at the end. We can see that for the distance, we have 2 digits of accuracy in every case. We'll start with 3 and then we'll round it at the end. Okay, so the b sub x, if you take cosine of 7 times 10, you're going to end up with 9.93. Okay, so we'll put that in there. And if you take the sine of 7 times 10, you'll end up with a minus. We already decided on the minus 1.22. And now we're ready for our next vector, and we'll call that vector C, and they're asking for 15 kilometers at 10 degrees west of south. And so we're going to do this one in blue. Once again, my drawing not quite to scale, but we want to go 15 kilometers. We came up 17, we went over 10, so we're going almost back down to where we started again, but only at 10 degrees west of south. So we're going to be kind of heading off in this direction for 15 kilometers. The angle that we know is this angle, 10 degrees west of south. And that leaves us with an unknown. If this is c hat, if this is the c vector, we have now a c sub y and a c sub x. This time, the c sub y is our adjacent side, so we're going to need to use the cosine for the c sub y. Last time we used it for the b sub x. So we can say cosine of 10 times the 15 kilometers would be the c sub y side. And then the c sub x side, we're going to say sine of 10 times the 15. And that's how we're going to come up with c sub x. Now, if you do the math on that, I did the math, and I will notice. Let's put in our negatives or positives. C sub y is going down, so it's a negative. C sub x is going backwards toward the negative x-axis, so it's also a negative. And if we go ahead and crunch the numbers through our calculator, we come up with a minus 2.60 for c sub x and a minus 14.77 for the c sub y. That's a 14.77. Which matches roughly with our picture. We can see that c sub y is much bigger than c sub x in our picture. Our resultant vector then, I'm going to draw that in black, is going to be how far are we from where we actually started this whole walk. Let's say we took a walk along vector A, B, and C. Really, we started from the 0, 0 point. We ended up right here. So our resultant vector is the one we're looking for. And how far off of the horizontal are we? So what we're looking for is a how many kilometers at how many degrees here. And we can simply do the math by, we can find the r sub x portion by adding these three. We can find the r sub y portion by adding the y components. If we took 0 plus 9.93 minus 2.60, you can pause and do the math. I come up with 7.33. And then if we take 17 minus 1.22 minus 14.77, we came up with Well, I did 14.77. You might round it to 14.8 and get slightly different number here, but it's all going to come out in the wash when we do the rounding. I got a 1.01. If you do 14.8, you might get a 0.98 here, but it's all going to work. So what we've done is we've found the R sub x and the R sub y components. We have found on this picture, I'm going to make it a little bigger. Here's our 0, 0 point. What we know now is we've got 7.33 in the x direction, we've got 1.01 in the y direction, and we've ended up at this point. We know two sides, and if we can use Pythagorean's theorem, if we know two sides and just want the third side, and that is a squared plus b squared equals c squared. It must be a right triangle, and c is always the longest side, the hypotenuse side, so c is the unknown in this case. If we solve for c, we would get the square root of a squared plus b squared, and we put the numbers in then, and we get 7.33 squared plus 1.01 squared. Take the square root of all that. I come up with 7.4, if I'm going to round it now to 2 digits. I come up with 7.4 kilometers. And that is my length of my resultant vector. But now we don't know. Well, the only thing left that we don't know is the angle. We do have this last formula here, and I always say go with your measured values if you can on this. So we can use the tangent formula because we know the opposite side of this angle. If this is the angle, the side that's opposite is this one. So we could say tangent of the unknown angle, the one we're trying to find, is equal to the 1.01, that's the opposite side, over the 7.33, that's the adjacent side. And then to find the angle, we're going to have to use our calculator and go tangent to the -1 of this whole bunch. 1.01 over 7.33. We do come up with, I came up with 7.84, but we have to round it to the least accurate of these, least degree of accuracy of these angles that we have. And 7 was only accurate to 1 digit, so we have to round this 7.84 to 8. So we're going to say at 8 degrees, and then we need to put a direction on it, and we're going east, but we're a little bit north of east, so we're going to say north of east. And this is the answer that we're looking for here.